So we'll continue graphing some sine and cosine functions, and then we'll write some equations of sine and cosine functions. So we're going to start by finding the sinusoidal axis, the amplitude, the displacement, and the period. So the sinusoidal axis, here's a shift down 7, that's our sinusoidal axis. The amplitude, the vertical dilation, is 6. The displacement, and we have a shift and a dilation both horizontal, so to find that displacement, we'll do pi over 2 divided by 1/4. So that's going to be 4 pi over 2. And because there's a plus there, that means that the shift is going to be left, and 4 pi over 2 is 2 pi. The period is 2 pi over b. So that's 2 pi over 1/4. So that's 8 pi over 1, which is just 8 pi. So we've got a period of 8 pi. Now we'll build our graph, starting with the sinusoidal axis. A maximum and a minimum. The sinusoidal axis is -7. The amplitude is 6. Add 6 and you get a maximum of -1. Subtract 6 and you get a minimum of -13. Our theta axis is going to be just above that -1, where x is 0, or where y is 0. We're displaced to the left, so I'm going to move my y-axis just a little bit to the right. We're displaced 2 pi to the left, so right about here we'll call that -2 pi. And that is where we're going to start our graph. 2 pi to the left. It is sine, so we're going to start on the sinusoidal axis. Cosine would start at the top or the bottom. It is positive sine, so we're going to go up first. If it was cosine, positive starts at the top, negative starts at the bottom. Our period is 8 pi, so after I go a quarter of a period, I should go 2 pi, which puts me right back at theta equals 0. So there is one cycle, and there's a second cycle. After completing one cycle, we have gone 8 pi units, starting at -2 pi plus 8 pi puts us at 6 pi radians. Another 8 pi radians puts us at 14 pi. So we need sinusoidal axis, amplitude, displacement, and period again. Sinusoidal axis, -8. Amplitude, 10. Displacement, it's plus, so it's going to be negative. So we're going left. And it's 60 divided by 5. That is 12. And we're in degrees this time, so it's 12 degrees. The period, normally for a period, we're going to put 2 pi right here over b. But because this is in degrees, on a unit circle, 2 pi gets us all the way around. So from 0 to 2 pi is all the way around. In degrees, that's 360. So instead of 2 pi over b, in this case, we're going to do 360 over b. So anytime you're in degrees, it's 360 degrees over b, and b is 5. 360 over 5 is 72. So we've got a period of 72 degrees. So here's our sinusoidal axis. Maximum and minimum. Sinusoidal axis, -8. Plus 10 is 2, minus 10 is -18, so there's our maximum and minimum. Between -8 and 2 is our theta axis. We're displaced to the left, so I'm going to move my y-axis a little bit to the right. And I can begin at -12 degrees. Since this is sine, I'm starting on my sinusoidal axis. It's positive sine, so I'm going up first. So there's one cycle and another. -12 plus 72 puts me right here after my first cycle at 60 degrees. Plus another 72 after my second cycle, I'm at 132 degrees. Now we're going to write an equation for a sine wave. For an equation, I need sinusoidal axis, amplitude, displacement, and V. Okay, so vertical shift is -17. That's my sinusoidal axis. Amplitude is 11. Displacement, phase shift, is 3 pi. And V is 2 pi over the period, which is 5 pi. So 2/5 is V. So Y equals my sinusoidal axis. It's sine. So 11 sine. And I'm going to write a factored form here. It's just going to be easier than distributing. V is 2/5. Theta plus displacement of 3 pi. But I actually have a displacement of 3 pi, which means in here, I'm actually going to want minus 3 pi. Okay, so that minus tells me it's going right 3 pi. Okay, again, S, A, D, and V. Vertical shift, 3/5. That's my sinusoidal axis. Amplitude, 8. Displacement, phase shift, pi over 3. V is 2 pi over the period. I'm going to put that over 1 over 3 pi over 7. 14 pi over 3 pi. So V is 14/3. Y equals sinusoidal axis, amplitude. Then I've got cosine, V, theta, and then the opposite of the displacement, minus pi over 3. And now I'm going to take all that same information out of this graph. S, A, D, and V. The sinusoidal axis is the average of the max and min. 2, and negative 4. So the sinusoidal axis, 2 plus negative 4 over 2. So that's negative 2 over 2. My sinusoidal axis is negative 1. Okay, so here's the sinusoidal axis. How high does it get above and below that axis? From negative 1 up to 2 is 3. And from negative 1 down to negative 4 is also 3. So I've got an amplitude of 3. Displacement. The first time I know a maximum or a minimum, and I know the radian value, I'll go right here. 3 pi is my displacement. Okay, so next I need b, which is 2 pi over the period. So after I complete one cycle, I'm right here. From 3 pi to 11 pi is 8 pi. That's my period. So I get a b of 1/4. So y equals sinusoidal axis. Okay, then I started on a maximum. Maximums and minimums are cosine. And since I started at a maximum, it's positive cosine. So plus 3 cosine. B. And then theta, and opposite of the displacement, minus 3 pi.
And we'll close this lesson with some review. So we've got sine, 7 pi over 4. Sine is a y value. And I'd like you to be able to see this in your head, but I'll draw a picture of a unit circle here. So 7 pi over 4, 8/4 is all the way around. We have to go back a fourth, and right here is 7 pi over 4. Okay, now there's positions here and here. That is the second position down. And in the second position down, the y value is negative root 2 over 2. Cosine is an x value. Okay, so it's negative, so we're going clockwise. And negative 3 over 2 is the same as negative 6 over 4. Negative 4 over 4 is halfway around. Negative 5 over 4 and negative 6 over 4 is right here. The x value here is 0. And then tangent is y over x. Okay, so it's 17 pi over 6. 12/6 is 2, so that's all the way around. 13/6, 14/6, 15, 16, and 17/6 is right here. Okay, so the y value, that is up one position. So that is 1 over 2. And for the x value, that is in position 1, 2, 3. So, and it's left, so it is negative root 3 over 2. Positive over negative is negative. These 2's in the denominators will cancel. So we've got 1 over root 3. And then I multiply top and bottom both by root 3, and I get negative root 3 over 3 for tangent. Okay, convert radians to degrees. So 5 pi over 2 radians. To convert to degrees, I multiply by 180 over pi. And these pi's will cancel. So I have 5 times 180 over 2. And that is 450. So we have 450 degrees. Now we have 5 pi over 2 degrees, converting that to radians. To convert 2 radians, we do pi over 180. So I'm going to get pi squared on top, and then 5 over 2 times 180. 2 times 180 is 360. So that's 5 over 360. And I'll convert that to a fraction, and we get 1 over 72. So it's pi squared over 72 radians. Okay, find the arc length. Arc length is S equals R theta. R is the radius, theta is the radian measure. Okay, so here is the arc length. We'll call it S. Okay, so the arc length is radius, which is 7 feet, times the radians. Theta in radians is 1.1. 7 times 1.1 is 7.7. So it's 7.7, and it is in feet. And last, we want to find the area of this sector. So the area inside of this sector, A equals 1/2 R squared theta. So A is 1/2 times radius squared, 7 squared, times the radian measure, 1.1. So 1/2 times 7 squared times 1.1 is 26.95. And it does say round to the nearest tenth. So to round this to the nearest tenth, we would actually round that 9 up to a 10. So it would actually be 27.0 feet squared.